That's not the hello.
Hello. Dankeschön, right?
Hola.
Okay. Hola. ¿Cómo está? Okay, anyway. Ni hao.
Kyla.
Okay, anyway, it's funny because in the YouTube, when you guys watch it later, the subtitles are all like, yeah, that's all there. Anyway. Okay, so now let's go through the errors. So I am redoing 5.4 example 8 because if you watched the video last time, I made a mistake. I used the average value formula and I shouldn't have. So what we're going to do is, it is, okay, anyway, let me just redo the problem. Okay, I'll just say to you some headaches. So now, first thing I'm going to do is I'm going to start off with, no, not that. I'm going to start off with this right here. So I know that somewhere in between there, okay, I'm going to find the average of where that's going to equal. So I'm going to go with it's f of u of b minus a. So that's going to be f of u. So now, what is f of u? So that's just put in u for my f, for my function, right? Okay, so so that's going to be u squared times 6 minus 2.
You redid this last time.
I didn't redo that because there was a part that I messed up on. Because I plugged it into the 1 over b minus a, when I shouldn't have. So this should be 4u squared is the value I'm going to use. Okay, that's where I'm going to find my u value where it's equal to the average of this. And so now for the next piece, so I got to make sure I don't screw this one up again. Okay, so for the next piece, I'm going to do the integral part. So where I do the integral part, it's going to end up becoming, let's see, so we have the integral of 2 to 6 x squared dx. So I'm going to end up getting x cubed from 2 to 6 over 3, right? X cubed over 3. And then let's go ahead and plug that in. So 6 to the third power is going to be, was it 218? 216, yeah. 216 over 3 minus 8 over 3, which gave me 208 over 3. This is the part where I messed up. Okay? This is the part where I messed up. So now I'm going to set this equal because I want to find the u value where it's equal to that part. So this is going to be right here. It's going to be, next page. So 4u squared is equal to 208 over 3 divided by 4. So I get u squared is going to be 52 over 3. And then I get u is equal to the square root of 52 over 3. It's going to be a plus or minus here also. But which one am I going to use? I'm going to use a plus because in my interval, it's going to be the positive, right? It's somewhere between 2 and 6. So now that I go ahead and plug that in the calculator, this should come out to be about like 4 point something. $4.163. You guys calculating? Or everyone just forgot what I was doing? No? Hey. Anyone calculating this, or am I just preaching now? Oh. Okay. So this was the value. Yesterday or Tuesday when we did this, it was like 2 point something because I messed up and I had a 1/4 in there somewhere, which messed up my whole thing. Okay. All right. Next one. Average value. So for this one right here, my f of u, my u value, which I found right here, should have been that, right? Okay, that's what I was looking for there. Now, for the average, remember, the y with the line over top, I think it's called bar. I can't, y bar? I'm trying to remember. Almost positive it's y bar. That's what you call it. Y bar. Yes. It's like one of those weird things. I don't know, like, kind of like what you guys, so instead of saying the actual real way of saying pi, you say p all the time, which is weird.
How do you say pi in P or pi?
P.
See? It's P. And you guys drive on the wrong side of the road. Come on.
We don't.
It's just like.
Then what do they do when they go to the bathroom? Pie?
Ah, thank you right there. Haha, that's great. All right. Anyway, average value y bar of a function of f is equal to the value of f of u in the mean value theorem for the integrals. So, average value, this is important. This is also on that flashcard that I told you to really pay attention to. I really need like some desk lamps or something. I had Christmas lights in here last year,
Yeah, you took them down this
but none of them work. I tried to put them up this year, but none of them work. Anyway,
I got
That's so sad.
I know. So we need some lights or something.
Buy a new Christmas lights.
You buy them for me. You buy them
You'll
for me.
need them next year anyway.
Okay. Anyway. All right. Okay. So yeah, I already did this one yesterday, right?
No,
No.
Yeah.
Yes, you did.
that was
yeah.
mine.
That was you.
I don't know.
No. Remember, you guys are all pissy. I was like, no. Look, you guys pay attention. This is
you said
easy.
yesterday?
I mean, Tuesday. Sorry.
No, he didn't.
Ah,
You
yes.
tried reading it. And
Listen. Okay. Are you ready? So if it's 1 over b minus a integral from a to b of f of x dx. Yes. Plug in. What is it going to be?
1 over 2 minus 0 from 0 to 2 of x cubed dx.
Okay.
So it's gonna be like 1 over 2.
So 1/2.
How do you
By
make
x.
X cubed?
Just put
Why
it-
did I what?
Oh, never mind.
It came from right here.
Yeah, I can see it.
Okay.
And it's gonna be x to the 4th over 4
X to the 4th over 4
from 0 to 2.
from 0 to 2, right? All right, so let me see. That's going to be 2 to the 4th should be 16. 16 divided by 4 is 4,
Yes.
right? And
Zero.
minus 0, right? 1/2 of 4 minus 0, which is just 2. Jess? Okay, good. Jess. All right, so rectilinear motion. This is actually, if I were to say what AP Calculus 1, like a typical type of problem would be this. Rectilinear motion is actually, it's the physics behind all this. Where we have net displacement, which would be, now, think of it like this. Over a graph, I have this graph right here, and this is distance over time. And this is t, distance over time. Okay, so, as I go right here, after 1 second, okay, I've gone here. That's my position, right? And 2 second, I'm right here. That's my position, right?
Listen.
And at 3 second, that's my position, right? But now, if I find the area of all this will give me my displacement, it's going to give me my area. It's the total distance traveled. So my displacement is the amount of area under that curve that I've actually traveled in this motion. Because it's possible to actually have a positive and a negative. So a lot of times I like referencing this, like me walking to Douche Brothers down the street, which is 1 mile. So if I start here and it's 1 mile, I go there, I have a positive displacement, right? Say yes.
Yes.
Okay, positive displacement. Now, I walk backwards from Douche Bros to here. Okay, just because I walk backwards. Okay, so what is going to be my net displacement?
0.
0, right? Because I have a negative. I'm going back this way, right? So my total displacement would be 0 from here. But is that my total distance traveled? No. It would be 2 miles would be total distance traveled, right? But my net displacement would be 0. That's the difference in between those things. Does that make sense or no?
Yes.
Okay, all right. So, net displacement or signed distance of an object whose motion begins at t equals a and ends at t equals b is given that from the velocity from A to B. V of t is the velocity. Okay? So when I'm doing this, that's the velocity there. But now if I total distance traveled, the total distance would be the absolute value. So whenever I have a negative part of this, that part's also going to be positive. So my displacement again, so I start here, I walk to Douche Bros, that's 1 mile, and I walk back. Since I'm walking back this way, I would have a negative velocity. So it's negative, so it's coming back this way. But the absolute value of that would give me a positive 1 mile. So my total distance traveled is the absolute value of the velocity when I take the distance from A to B. I said a lot. Did I say too much?
No.
It's fine.
Oh, okay. So
It's just
okay, so if velocity v of t is greater than 0 for a and a is less than t and t is less than b, then the net displacement and total distance traveled are equal. Okay? Someone explain what that means.
if the velocity is going to be greater than 0.
Okay, so now in my terms of the analysis of going from one place to another, what does that mean?
If we go in one direction, like.
Yeah, if you're only going in one direction, it's always going to be positive.
Yeah.
Thank you. That's where we're going. So if it's only going one way, so it's always going to be just positive right there. All right, an object in rectilinear motion is moving along a horizontal line with the velocity, v of t here, in meters per minute. Okay? In meters per minute. So from the time from 0 to 6, find the net displacement. Net displacement. So let's go ahead, let's do a net displacement for this. So now for this, it's going to be from where to where? 0 to 6 of my function 3t squared minus 18t plus 15 dt, right? Yes? Okay, so let's go through and actually do some. It is so dark in here. Like, I can't even see what's going on, so I'm going to help you guys out. I'm going to put like this lamp right here, see if that helps.
Oh.
Do you have any paper towels?
Huh?
Do you have any paper towels or nothing?
It helps really only put.
Okay. All right, so given that, so let's go ahead and do the integration here. So it's going to be, what's that going to be? T
T cubed.
cubed, right?
D3
Over 3, but the 3's cancel, right?
Oh yeah.
Okay, that is going to be minus,
9t squared.
so t squared, right?
9.
I know, it's going to be 9, but if it's squared, it's over 2, right? So 18 divided, whoa!
Wait, how does it
Oh my god, I thought the bottle was lit.
Okay, so you ready?
Yeah.
So, when this goes t squared, isn't it over 2?
Yeah.
And so what's 18 divided by 2?
No,
Yeah.
the one before.
the one before that, doesn't this become t cubed over 3?
Yeah.
What's 3 divided by 3? That's where that goes. All right, then it's going to be plus 15 t from 0 to 6. All right, you ready? Okay, let's do it then. So 6 to the third, what do we say that was? 216. Okay, minus 6 squared is 36 times 9. 324. Y'all got calculators, but you know some people just sitting there picking noses. 324.
Yeah.
Okay.
Believe me.
I'm not saying I don't believe you. I'm saying that
Yeah.
I'm like preaching here, and like other people are like got a calculator in front of them, and you know, dang it. Okay. All right. 324 plus 90. Okay. And that's minus the lower bound, which is going to give me what? 0. Okay, so all that's going to be 0. So it's going to give me what?
Negative 18.
Negative 18?
Yes.
So I have negative 18. So, and that's going to be in my units. What does that mean?
That's matters per meter.
Okay, no, because this is velocity. Velocity is the distance over time, right?
Oh, it's meters.
And this is going to be, it's right here, right? The net displacement. So it means how far did it go? So it's negative 18 meters. So that means that from the place we started, okay, right here, right?
Yeah.
So we went forward and we went back. So, but we went back further more than what we went forward, right?
Mm-hmm.
So we're at negative 18 meters from the point that I started. Yes?
Yes.
Is this making sense?
Yes.
You know, I like this because it does make sense. It has very direct application. Okay, so the next one says, find the total distance traveled from 0 to 6 and interpret the result. Okay, so it's going to be 0, 6, right? Absolute value of
3t squared minus 18t
plus 15, right? And that's going to be dt. Okay, so now for these things right here, I got to find out where this is equal to 0 first. Because when it's equal to 0, that's the point where it turns. Okay? That's the point where it's going to end up turning. So it's no longer going to be positive there. And then that part also has to become positive. So let's see. So starting this off, so where it's going to be equal to 0, that's where I'm going to change the parts. Okay? So let's just do a basic absolute value. Okay? So if I have an absolute value of, okay, before, so let's just say I'm going to have the absolute value of 3x, negative 3x. Absolute value of negative 3x. Okay? So if I'm going to do that, I know that's going to be equal to 0 somewhere, right? Okay? So somewhere it's going to be equal to 0. So let's go ahead and plug this in. So it's going to look like this. It's going to be negative 3x equals 0. And then divided by negative 3. So x equals 0. So x is going to be the place where the function changes direction, right? So that means that my graph is going to look like this. My graph looks like this. Of this absolute value function, it's going to look, and when it hits 0, what happens? It bounces back up, and it goes back this way, right? And so where equals a 0? So if I'm finding the area, of this from, let's say, -2 to 2, no, it's not going to be 0. No, it's not going to be 0 because it's going to be right here.
Area is always a positive.
Yeah, so, no. You can have a negative area because that's what we're getting with this displacement.
Yeah, but
Didn't we come up with a negative when we did the integration there on that previous problem? Because that means if I have my graph, that means more was beneath the graph than was above. So in this case right here, so this is me walking to Douche Bros, right? Yes?
Said walking back.
Okay. Me walking to Douche Bros, right? From here to there, I walk to Douche Bros. So I have a total distance traveled there. But now, going from there back, if I were to continue this, wouldn't it look like this? And when I was done, what would happen? I would end up with 0, right? Because I would end up back here. So I would have a positive going that way and a negative coming back, right? So positive going that way, negative going back. But now since I found out where this is equal to 0, I set it equal there, and now I turn it. So that piece right there in my graph is now going to go up. So right here, there was my going this way, my absolute value portion. And so now I add this area and that area. And so now I know going from here to Douche Bros is 1 mile, but walking from there back is also another mile. It's not a negative mile, right? Because coming back this way was a negative velocity, but then I absolutely valued that velocity. Does that make sense now?
Yeah.
When I do it like this, does this piece right here make sense? Yes? No? Speak. No?
I just velocity thing confused me.
Okay, remember, velocity is distance over time.
Oh, okay, yeah.
Velocity is distance over time. So it's going to take me 15 minutes. My distance over time, my velocity from here to there is going to give me, whatever that is, right?
Okay.
That's my velocity. So there's my motion right there.
Okay.
And then I'm just going to go distance over time right there. And then the total distance traveled is from here to there, and all the ground that I covered.
All right. that makes
Mr. Butcher.
Yeah.
Is it distance over time in this graph?
Yes, it is distance
But
over time.
can time be negative?
I'm just using it as this right here. For this one, it's not going to be.
Oh, okay.
I'm just trying to use this as an example so you guys could understand that I had to find out my 0 to be able to go from here to there. And so from there, I was just using this as an example. It's not, if you notice, these are X's and they're not T's. Okay, so that's what I was meaning for that. All right, are we all okay now? Okay, so we all feel pretty good about this, right? So let's go ahead and, okay. Okay, so now let's find out where this thing is equal to 0. All right, let's find where this is going to equal 0. So let's F that. So what am I F'ing out of that? Say a 3.
3.
Okay, and I'm left with t squared minus 6t plus 5. 3 factor of, what is that going to give me?
Oh, it's gonna be like t minus 1.
Minus 1 and
Minus 5.
minus 5. Okay, so it's going to change directions at t equals 1 and t equals 5. So let's change directions at those two places.
Isn't that supposed to be then? Oh wait, so it was going back then first, and then.
Yeah, he was going down first, right? So, but then if I look at my graph, let's actually do this. Let's graph this so you guys could actually have. So I'm gonna graph this. So I need you guys to help me with this when I change menus. So, okay. So what was my function?
3t squared.
3 squared
minus 18t
18t
plus 15.
plus 15. And now what is going to be my integral now? So I'm going to change my menu so you guys could actually look and see this a little bit better. So let's go from 0 to 6. Enter. There we go. Okay, so right here, from here to here, that's my 1, and that's my 5, right?
Yeah.
Okay, so now, that's what it's going to be. So the area under this graph would be from here, right? This portion here. This portion down here is negative, right? And this portion over here is positive, isn't it? Yes? Okay, so this is going to be positive, positive, and in between here is going to be negative, right? So let's go ahead. So now I have those. So I'm going to break this up into the different parts. I'm going to break it up into the different parts now. So my integral is now going to be changed to, so it's going to be my integral from 0 to 1 of my function, right? 3t squared minus 18t plus 15, right? Actually, do you know what? Let me just f of x this. Or f of, or it's v of t, right? Yeah, v of t. V, come on, brain, work. All right, so v of t dt, right? And it's going to be plus the next part, which is going to be a negative, right? So it's going to be from 1 to 5 v of t dt, right? But this piece is going to be negative, so I'm going to absolute value that, plus the next piece, which is from 5 to 6 of v, oh, come on now, v of t dt. So absolute value functions are kind of a pain, but it is helpful to figure out the total distance traveled on this. So now, so we already did the integration earlier, right? So we did the integration earlier, so it came out to be, what was it? So it was from, was it t cubed minus 9t squared 15t from 0 to 1 plus absolute value, right? Absolute value of t cubed minus 9t squared plus 15t.
So the absolute value is not like changing anything and finding antiderivative. It's just gonna be.
Yes, because you only want the positive part of all of this.
No, I know. I mean, like when we find antiderivative of the absolute value, it's not different. It's just
No, it's just you have to change your parts. You have to change your bounds. And what's that going to be from, was it 1 to 5 plus, and this one's going to be my t3 minus 9t squared plus 15t from 5 to 6. Right? Okay, so let's go ahead and right there, this is going to give me 1 minus 1 plus 1, no wait, hold on, 1 minus 9, negative 8, plus 15, 7, minus 0, right? Plus,
125.
what do we get? 125?
Wait, -100 plus, it's 100 minus 25.
25?
Yeah. Negative.
negative, but absolute value means it's
So it's just this time.
should be
And minus 7 because we're plugging 1. So wait, it's gonna be negative 25 minus 7, so it's gonna be.
Yeah, it's negative 25 minus 7. So
oh, okay, negative 25 minus 7, thank you. And so that's going to give me a positive 32, and then plus my, crap, that one sucks.
So it's gonna be 216 minus 36. Oh wait, we found this one in last.
Yeah, that was what?
18.
18.
That was negative 18.
So this
Yeah,
is
negative 18.
negative 18
Minus negative 25 because we're plugging
negative 25.
that.
So right here, negative makes that a plus. So together that net gives me what? 7. So I have 7, 7, and 32. So 14 plus 32 is, what is it? 46. And so that's going to be my what?
Like this.
Okay, but what did we call this one? What do we ask for?
Displacement.
So this one asks for the total distance traveled. So total distance travel on here, so my total distance is 46 meters. All right, so let's go back to the calculator right here, and I'm going to bring up this, and okay, so enter. So it looks like this. Menu, analyze graph, integration, from 0, enter, 6, enter. 46. Now, is the calculator showing you this right here help out? So you can actually see that the middle piece right there breaks up and it has to stop and turn upwards on that? Or no? All right, so we have, that was it?
Yeah.
Yay! All right, don't forget, like, share, and subscribe.